Okay guys, I'm back. This is still chapter 6.1. I had to turn off the video because I was running low on battery. Basically, we already did this page right here, and we just did the back. So now we're on the next one. There's no EQ because we're continuing chapter 6.1 of the notes. It looks like this right here. Okay, so a couple of things for Cornell Notes. We're going to learn something new. Whenever you see these three dots mean therefore. And you're probably familiar with W/ means with and W/ out means without. So here's a freebie Cornell note, but this is not really science related. This is Cornell Notes related. It's a shortcut whenever you write notes if you use these symbols. So if you see these three dots, it means therefore. Okay, if I write W/, that means with. If you ever see me write W/ out, without. Okay, all right, let's continue. Chemical changes occur when bonds break, the atoms rearrange, and new bonds form. Think of it this way. We've done this before. Remember that we played with the Legos? You know what? My bad. That was with my 7th grade. I will do that when we come back. But if you ever played with Legos, you take the Legos and you put them together. Let's say you have 5 blue and 5 red, and you put them in a certain order and you build like a little house. Okay, but now when you want to build something else, you take the Legos apart and you take your 5 blue and your 5 red and you build something different. Now, notice that you rearrange the Legos in a different order. That's chemistry. You started with 5 blue and 5 red, and you just put them in a different order. Same thing in chemistry. You have all these chemicals arranged a certain way, and when you do a chemical change, you pull them apart, put them in a different order, and now you get a new substance. So chemical changes occur when you break and rearrange these bonds. Now, new substances with different chemical properties are found. Going back to the previous page, we talked about how water was made up of hydrogen and oxygen. H2 is highly flammable. It'll blow up in your face if you light up a match. O2 is also flammable. If you know anyone, if you have like a grandparent that's on an oxygen tank, it'll be a green tank. And if they're on a respirator, you'll see warning labels on that oxygen tank that you can't be smoking near it or keep it away from flames because pure oxygen will explode. So here you have two chemicals that could explode: hydrogen gas and oxygen gas. Two highly explosive, dangerous chemicals. Put them together, you get water, which is like the complete opposite of explosion. You use water to put off fires, not cause them. So whenever you have a chemical reaction, the new chemicals can actually behave way different than their original chemicals. Now, here's two key terms. A reactant is a substance that undergoes a change in a chemical reaction. Think of your reactant like if you're baking a cake, your reactants are your ingredients, and the product is your cake. The product is a new substance that's being formed. So here's a chemical equation. Here we have magnesium, and we talked about the Lewis dot structure. These two red dots means that it has 2 valence electrons. So magnesium has 2 valence electrons. We have 2 magnesium. And here we have oxygen. Now, remember, the oxygen has the octet rule. You're supposed to have 8. Now, if you look at this, there's 1, 2, 3, 4, 5, 6, and this one has 6. But if you cover this oxygen, I see 8. There's 8 oxygen right there. And if you cover this oxygen, there's 8. So basically, the oxygen are sharing these 4 in the middle. Therefore, each one technically has 8. Now, if you break the bonds, if you pull them apart, what happens is the magnesium can now hook up with this oxygen. Oxygen has 6 plus 2 would make it 8. And now this one has 6 plus 2, it makes it 8. So the oxygen will break this double bond right here, hook up with magnesium, and what you end up is basically magnesium loses 2 electrons. But now the oxygen has its octet again. Now, written more simply, without the Lewis dot diagram, it's basically 2 Mgs, 2 Mg, plus O2, 2 oxygen, give you 2 magnesium oxide, MgO. MgO, there's 1, there's 2. So we're going to learn later the conservation of mass is that we started with 2 magnesium and we end up with 2 magnesium. We started with 2 oxygen and we end up with 2 oxygen, because this 2 means that there's 2 of everything: 2 magnesium, 2 oxygen. You should already know that this symbol means at, and RT means room temperature. It got a little cut off in my notes, but right here it's properties at room temperature. Okay, now notice how these chemicals are completely different once they hook up together. Magnesium melts at 650 degrees Celsius, which is pretty decent. but you know, it's not super high temperature. It could be melted, but there's other metals that melt at much higher temperature. And magnesium, if you melt magnesium and you want the melted magnesium to boil, it boils at almost 1100 degrees Celsius, okay? Now, at room temperature, magnesium is a silver white solid, and it could explode. It's actually pretty dangerous. Now, look at oxygen. This is what we breathe. It has a melting point of negative 219 degrees Celsius. That means that if you want to turn oxygen into a solid cube, like an ice cube, it'd have to be lower than this. It'd have to be negative 220 degrees. So oxygen has to get super, super cold to turn hard. Now, it boils. It turns into a gas at negative 183 degrees. That means that you need to get it at negative 184 for you to have liquid oxygen. So if you have a tank of liquid oxygen, do not put your hand in there. It'll freeze right off. Oxygen is colorless and odorless and tasteless at room temperature, and as I mentioned, very flammable. But look what happens when you combine magnesium and oxygen. It has a melting point of 2800 degrees. It boils at 3600 degrees. It is fire resistant. This is what we use in buildings, and we cover even metal in high-rise buildings with magnesium oxide to help the metal not melt in a fire. For instance, scientists think that in September 11, when the airplanes hit the Twin Towers, one reason why the buildings collapsed is because the impact of the plane hitting the building actually shook and broke off the magnesium oxide that was covering the metal. And because there was no more of that fire retardant property, the metal did heat up. Now, the temperature of the fuel in the airplanes wasn't enough to melt the metal, but it was enough to weaken it. And with all of the weight of the building above it, it collapsed it. Had the magnesium oxide stayed on the metal, it could have given precious more moments for people to escape. So this is very important. This will make, they'll even put, like I said, put it on metal to help it from melting in case there's a fire. But it's also used in many fire retardant applications. But it's kind of weird how magnesium is explosive, oxygen is flammable, but you put them together and it becomes something completely opposite. It's fire resistant. All right, last page of notes. Now, how do we know that there was a chemical reaction? What's the evidence? Well, chemical reactions will usually produce something that you can see with your eyes. Sometimes you can see both. Sometimes you'll see a change in its property, like a physical or a chemical reaction. For instance, you might see the paper turn into ash. You saw it with your eyes. And that was a physical change. But sometimes it'll be a chemical change. When you burn that paper and it's releasing heat, you can feel it. So that would be changes in energy. Okay. Now, changes in property. These are some things you could observe when there's a chemical reaction. Reactants may change color when forming a product. So if you mix two clear liquids and they spontaneously turn red, and that is possible, there are some liquids that will change color when you add them, that is an example of a physical change. Sometimes you mix two liquids, and when you stir the liquids, this like white powder, sometimes it'll be a different color, but sometimes it'll be white powder, just like starts raining down in the cup. That's called a precipitate. That happens when there's a chemical reaction, usually with two liquids, where they'll actually form a solid. Sometimes you might mix a solid and a liquid, and it starts emitting a gas. So if you combine liquid and a solid, and instead you get a gas emanating from it, that was a physical change. Now, you might have a chemical change. For example, the product may have a vastly different melting and boiling point, like we saw earlier with magnesium and oxygen. Magnesium and oxygen had lower melting and boiling points, but when you made magnesium oxide, the boiling point and the melting point was 10 times the difference. And here's another one. The product may be more stable or more volatile. Magnesium is flammable. Magnesium is explosive. Oxygen is flammable. You put it together, it's flame retardant. And look at water. Hydrogen is explosive. Oxygen is flammable. You put it together, you make water, which is the opposite. So when you mix two chemicals and the new chemical behaves completely different, that is usually a telltale sign you had a chemical change. Okay? Now, here's another one, changes in energy. We did this lab. Remember we did the instant ice pack and the instant hot pack? We opened it up and there was like that white powder. Remember for the instant ice pack, we mixed water, and what happened is your hand felt cold when you touched it. What's happening when you do the instant ice pack is heat is actually entering the ice pack. That is called endothermic because energy is going into the ice pack. So when you activate the ice pack and you put your hand on it and your hand feels cold, it's because it's actually sucking the heat out of your hand and into the ice pack. The heat is going in. So when it's entering, it's endothermic. So think of EN, endothermic, N as enter. Chemical reaction where bonds are broken. And what happens is energy is being absorbed. Another example is when you cook an egg. When you're cooking food, you might be thinking, wait a minute, but when I cook that egg and put it on my plate, I feel heat. If you put like your hand above the egg, you put your hand up here, you might feel the heat. Well, that's after it's done cooking. But in order to cook the egg or in order to bake a cake, you need heat to enter your food. So the heat has to go into the food. That's how it cooks it. If you put like cake batter in the oven, the heat has to go into the cake batter. So that would be endothermic. Now, exothermic is the opposite. Exo means exit. Energy is leaving. So look at like the instant hot pack. We did that one too in our lab. We opened the hot pack and it had this white powder. We mixed it around, and when you touch the bottom of the beaker, your hand felt hot because right here it's a chemical reaction that's releasing heat. An example would be of an exothermic reaction would be if you burn paper. If you burn paper and you put your hand above it, you feel the heat hitting your hand because heat is exiting. So those are the two different ways that energy will be exhibited in a chemical reaction. Is heat entering the reaction or is heat exiting? Now, some reactions release heat, but very, very little. For example, when iron will rust, when you have like a piece of metal that's outside in the rain and it turns into rust, it actually releases a tiny amount of heat. You just don't feel it, but it's very, very small. Some of these instant hot packs, like if you ever buy hot hands, not like the one we did in the lab, those are white powder, but if you ever buy those instant hand warmers, if you open it up, it's actually metal shavings. It's tiny little pieces of metal dust. And when you open up the package, the moisture in the air starts to rust it. And it creates enough heat that you could feel it. The only way that works is because the metal has been shaven down to a fine little powder. But if you have, like if this pen was a solid metal and it started to rust, it would release heat, but it would be such a tiny amount the human body can't feel it. But if you're a scientist, you'd be able to measure it. So exothermic reaction, an example would be metal that would be rusting. Okay, that's it for the video. I'm going to put the chapter 6.2 on Wednesday the 18th. Until then, work on the notes. Remember that you have to work on the wanted poster. That is still due, except I won't be collecting it on March 27th. I'll be collecting it the Monday we come back from this quarantine. Remember, stay home. There's no need to go outside. And the CDC is recommending that you avoid crowds of under 50. So that means no movie theaters. If you're going to go hang out with friends, just limit your contact. Try to keep 3 feet apart. This is serious. I mean, it's going to get way worse before it gets better. Be safe out there. Even though you're young and your immune system is strong, think about the people in your family that are immunocompromised. Someone that might have respiratory problems, asthma problems, someone that's elderly, a newborn. Someone in your family might be going through cancer treatments, chemotherapy. This virus can be potentially deadly for them. So stay indoors, just start binging on Netflix, play some Xbox or PlayStation, and just stay home and be safe. I'll see you guys again on Wednesday. Bye.